Hi everyone, good to see you all. Today I'm here to present about RCNN with a great feature hierarchies for accurate object detection and semantic segmentation. I divided my presentation into 5 sections. First, we will introduce team member and then move to the problem state and our solution includes naive solution with the sliding window and RCNN. The last is references. My group has for people like this. Now let's move to the first section. In the computer vision, we have 3 main problems, which is about classification, detection, and segmentation. The first is image classification, which determines object in image. For example, this image of a cat can be classified as a cat label. The next is image detection. It takes an image as input and produces one or more button box with the label attached to its button box. In the second picture, there's a yellow button box for cats and a red button box for dog. The last one is image segmentation. This is a partition segmentation, which we mark the regions for each object in the image. In the third picture, we see a picture of a dog and a cat with their specific shape. My project is about detection. Image detection is widely used for automated car security industry. For example, using a camera for smart home and augmented reality. Well, I have to tell you about all problems today.
For image detection, we provide you 2 solutions. Firstly, we approach with a naive solution, which is the sliding window. We already know that we can use the CNN or convolution neural network to classify an image. For instance, we can see the image of a cat, and after passing through the CNN, we have achieved that this image contains a cat instead of a dog or a bird. So the sliding window combines the sliding window technique and the CNN for detect the image. First, we can see that it creates a red window on the top left of the image, and it crops the image into a smaller pieces. Then it pass this piece into the CNN and it detect whether this image contains a cat. Next, it moves the window to the right and crop the image at that position to create a new smaller image, and also in the same way we pass it into the CNN. The sliding window will move the window to the next position and crop it each time we move. So the sliding window we use for a large image is we can place a window on the top left and move it to the right and move down until we reach the bottom right position. However, the sliding window has some disadvantage. First, we don't know how to choose the window size, which size is the most suitable for our problem. The next problem is after each run, how many pixels do we need to step? And lastly, we can see that the computation of the sliding window technique is very expensive, so its performance is very low. Now we provide you a new solution, which is called RCNN, or also known as region-based CNN. Instead of using the sliding window to crop the image into smaller pieces, the RCNN uses the region proportional algorithm to create many interesting regions. For the region proportional, there are many algorithms we can use. However, in RCNN paper, they use the selective search. In the left image, we can see that it creates many bounding boxes. However, this bounding box is not very interesting. They will merge this bounding box into the larger one. For instance, you can see on the right side, we can achieve the bounding box contain a person. And this is the full models of RCNN. With the input image, it uses the selective search to extract many interesting regions and then put them into the convolution neural network to extract feature. Which is extracted, we pass into the SVM model to classify the class of the image, and because of selective search is provide the interest region. However, the bounding box is not very accurate, so we also pass the feature into the bounding box regression to achieve the better one. In our project, we will reference 3 papers. The first one, which is the rich feature hierarchies for accurate object detection and semantic segmentation. In this paper, they use the selective search, so we also reference from the selective search for object recognition. And because the selective search is use an algorithm called efficient graph-based image segmentation. So these are 3 papers we are reference from. So that is all for our introduction. Thank you for listening.